To multiply and divide rational expressions, let's remember how we multiply fractions first. Remember, a rational expression has a ratio in it or a fraction. So let's just remind ourselves of this really fast. If we have 2/3 times 3/14, remember, multiplying fractions, you just multiply straight across, numerator times numerator and denominator times denominator. Now you can go ahead and multiply 2 times 3 and 3 times 14, or you can choose to think about it like this and make your life a little bit easier possibly. Keep those factors separated first. All right, so we have 2 times 3 and 3 times 14. What do you have in both the numerator and the denominator that can reduce down? Well, they both have a 3, so 3 divided by 3 gives us a 1. And then 2 and 14 are both divisible by 2. So 2 divided by 2 is 1, 14 divided by 2 is 7. We can reduce these fractions first. Now multiply. Our numerator is just the number 1, and our denominator is just the number 7. So a lot of times it's easier to reduce first and then multiply across. So let's look at this first example right here. We have this rational expression, and it's already in factored form for us, which is really important because we cannot simplify or reduce any addition or subtraction pieces of our expression. They've got to be actual factors, okay? They have to be the values that we multiply together to make our expression. All right, so we start out in factored form. What do you see that we have in common in both a numerator and a denominator, right? So we want to look at both numerators as 1 and both denominators as 1. Okay, do you see any factors that we can reduce or simplify? Well, I have an x minus 4 in my numerator and an x minus 4 in my denominator. So both of those reduce. And remember, it's always just an expression divided by itself is just 1, okay? I also see an x plus 2 in my numerator and my denominator, so those will reduce to 1 over 1. And then I also have an x minus 3 in both my numerator and denominator, so those are also 1 over 1. So this simplifies to the number 1. And the reason that I kind of wrote all of these ones down is to remind you when a value is divided by itself, we do not get 0. A lot of people want to say cancel out, but they don't actually cancel out. They just reduce to the number 1. So keep that in mind when you are simplifying your rational expressions. If everything reduces down, we're left with the number 1. Okay, second example is not in factored form, right? We have our expanded form with addition and subtraction here. We need to break these down into its factors. What do we multiply together to get each one of these? So I'm going to go ahead and do a little bit of side work here. I look at 3x squared minus 27, and of course we always look for a GCF first, a greatest common factor. So I can divide out the number 3 in my numerator, and I'm left with x squared minus 9. So there's that one. Of course, this denominator and this denominator are already linear factors. I can't simplify those anymore. I can't break them down into any more factors. But if I look at x squared plus 2x minus 15, my a value is the number 1, and my c value is a negative 15. So what are the factors of negative 15 that combine to give me this positive 2? So I start with an x in each of these, and the factors of negative 15 that combine to give me a positive 2 are a positive 5 and a negative 3, right? When I multiply them together, I get negative 15. When I add them together, I get a positive 2. Okay, so now I look at this and I say, is there anything else that I can do? Well, go ahead and cross that out. This x squared minus 9 is the difference of two perfect squares. So let's go ahead and rewrite this. We have 3, and then I am going to factor out x squared minus 9 into x plus 3 times x minus 3. My denominator doesn't change. I can't factor that anymore. And there's nothing that I can do to factor x plus 5 times x minus 3 anymore either. It's all the way broken down, and x plus 3 is my denominator. So now we look at both of our numerators as 1 unit and both of our denominators as 1 unit, right? What do you see that you can simplify? What can we divide out of both the numerator and the denominator? Well, I see right here that I have an x minus 3 divided by x minus 3, so those reduce to 1. I have an x plus 3 in this numerator and an x plus 3 in this denominator, so those both reduce. And we're left with 3 times x plus 5 times x minus 3. Now this right here is our factored form, right? This is our factored answer. But if you want to an expanded answer, you can always go ahead and multiply those back out, okay? Just remember you would just double distribute, right? Well, let's go ahead and do that just for fun. So we end up with 3 times, we have x squared minus 3x plus 5x. So that's x squared minus 3x plus 5x gives us that plus 2x, and then minus 15. And if you need to use the box method to multiply that back out, you can. And then, of course, distribute that 3 to all of your terms. You have 3x squared plus 6x minus 45. Again, both of these solutions, both of these answers are exactly the same, just one is in factored form and one is in expanded form. All right, let's go to another problem. How do we divide fractions? So if you want to divide two fractions, you just keep your first fraction the same, 2/9. You change your division sign to multiplication, and you use the reciprocal of your second fraction. So we're going to multiply by our reciprocal. So we have 2/9 times 3/10. Now again, remember, use your numerator as 1 unit and your denominator as 1 unit, right? What can you divide both of those by? Well, 9 and 3 are both divisible by 3. So 3 divided by 3 is 1. 9 divided by 3 is 3. And 2 and 10 are both divisible by the number 2. So now this multiplication problem is a lot simpler. We have 1 in our numerator and 15 in our denominator. So remember, when you're dividing, you just multiply by the reciprocal of your second fraction. So let's look at these. Again, we're going to have to factor first. So x squared plus 3x minus 4. What are the factors of negative 4? The factors of negative 4 that combine to give us a positive 3. I know positive 4 times a negative 1 multiplies to give me negative 4 and adds to give me a positive 3. So we're going to use x plus 4 times x minus 1. Okay, that's our numerator. Our denominator, what are the factors of positive 8 that add to give me 6? Well, I know 4 times 2 gives me 8, and if I were to add those two factors together, we would get positive 6. So we'll go ahead and factor this into x plus 4 times x plus 2. All right, now let's go ahead and factor our numerator, x squared minus 4x plus 3. What are the factors of positive 3 that add to give me a negative 4? Well, the only factors of 3 are 3 times 1, unless you multiply by a negative 3 times a negative 1. Those multiply to give you a positive 3, and when you combine them together, when you add a negative 3 plus a negative 1, you end up with your negative 4, that b value. So we'll use x minus 3 times x minus 1. And of course, our denominator is just x minus 3. We can't factor that at all. So let's go ahead and rewrite our first fraction. We have x plus 4 times x minus 1 over x plus 4 times x plus 2. And remember, we change our division symbol to a multiplication problem. So this is times. And then we need the reciprocal of our second fraction. We've got to flip this fraction, right? So this turns into x minus 3 in our numerator. And our denominator is that x minus 3 times x minus 1. And remember to treat both numerators as 1 unit and both denominators as 1 unit. And what can we simplify? Well, we've got an x plus 4 in both the numerator and the denominator. We've got an x minus 3 in both numerator and denominator. And I've got an x minus 1 in this numerator and in this denominator. So in the numerator, we've simplified everything. It doesn't look like there's anything left. But remember, when you simplify everything down, that just ends up being the number 1. And our denominator has x plus 2 left. So that's all we can do with this one. This is as simplified as we can get. All right, last example. We've got 4x squared minus 25 in our first numerator, and I don't see a GCF for that, but I do recognize that 4x squared is a perfect square, 2x times 2x, and 25 is also a perfect square, 5 times 5. So this is the difference of two perfect squares. We've got 2x plus 5 times 2x minus 5. All right? And then I look at our denominator, 5x squared minus 25x, and I do see that they both have a 5 and an x as a GCF. So let's factor out a 5x, and we're left with x minus 5. And then I look at my second fraction, and 2x plus 5, that numerator doesn't simplify down. And x squared, I guess if you wanted to, you could go ahead and write x squared as just x times x, if that helps you think of it that way. All right, so let's rewrite this problem. We've got 2x plus 5 times 2x minus 5 divided by 5x times x minus 5. And then we need to change our division problem to a multiplication problem and use the reciprocal of our second fraction here. So we have our new numerator is x times x, and our denominator is 2x plus 5. So what can we simplify down here? Well, I see that this denominator has a 2x plus 5, and so does this numerator. So those reduce 1 over 1. And then as I look at these, I can see that this is an x term here and here. That's kind of why I wanted to separate out that x squared so that you would pay attention to that, right? We can simplify out one of these x's and this x value. And as I look, I don't see any other common factors. So our numerator is just x times 2x minus 5, and our denominator is 5 times x minus 5. And none of those simplify down any further, so this is our factored answer. Now, if you needed to expand this problem, you'd end up with 2x squared minus 5x, and our denominator would be 5x minus 25. That's our expanded answer. All right, have fun.